right, Colton, let's answer that badass question. And I want to make sure you heard Colton's badass question. He asked, wait a minute, Sean, we had margins of error that we had to attach to 47 and 29%. And the reason we had to do that was because we have a small sample. It's not based on entire population. But then we just also mentioned the fractions 2/3 and 1/3. 2/3 is the chance that you win if you switch, and 1/3 is the chance you win if you stay. Why don't those need margins of error? Why don't those need margins of error? Anybody want to try the answer? This is a tough question. It's again a 244 question.
Well, the only reason why I think that they should is because I thought there always has to be a margin of error to stats.
When do you need margins of error?
When you can't test every single.
When you can't test every single element of a population. That's why we needed a margin of error. I only tested 38 total students, broken into two groups, 17 and 21. The 1/3 and 2/3 were found because we were actually able to enumerate all the elements of the population of what could happen. Now, it turns out there aren't very many. There are only 9. The prize could be, better yet, I'm gonna put it up on the screen, rather than me talking through it, because I think visuals are better than me talking for so many reasons. Let me put the actual 9 elements on the board again. I'm not sure if we looked at it. We may have looked at this in class. I'm not sure if we did or not. Oops. Oh, you can't see that yet. Okay, let me go back to the website. Okay. Course info, resources, down here. This is only one. Yes. Right here. Okay. So we may have looked at this. I'm not sure if we did or not. There really are only 9 things that could possibly happen. You pick door number 1, and the prize is behind door number 1. You pick door number 1, and the prize is behind door number 2. You pick door number 1, the prize is behind, and so forth. There's only 9 things that could possibly happen. So in other words, there's no need for a margin because we literally can enumerate the entire experiment. This is kind of, I'm glad that makes sense. That makes me very happy that it makes sense. The shortcoming of it is this only works in a very limited number of experiments, like Monty Hall, like a roulette wheel, like a game of craps, like a one-armed bandit at a casino. Everything else that you don't know the probabilities of, you have to study via a sample. And as soon as you take a sample, you have to put a margin of error on it. Does that kind of make sense? This is why actuaries are paid so much. They're the folks that set rates for insurance companies. They're the ones that tell insurance companies how much they have to charge their consumers for their monthly premiums and how much they should pay out if an accident happens. They've got to be correct with those numbers that they're using. We'll study more of that in the in-class quiz on Wednesday. I'll show you how an actuarial quiz kind of works. But if they don't get those percentages right, they can bankrupt the company by either not taking enough money in or spending too much money out. That's why Katrina buried so many people back in 2005. My God, that's almost 15 years ago now. But so many insurance agencies went bankrupt after Katrina because so many of them had overestimated the chance of those levees holding. They said, oh, we don't have to worry about collecting more premiums, even though those people are living below sea level next to the Mississippi River. I remember being there in 1995 on tour and walking by the levees and being like, those things are leaking. They're like, oh, it's fine. I'm like, I don't think they're supposed to leak. I mean, I'm like just idiot guy from Delaware who doesn't live under sea level, but I'm like, they're leaking. There's a big river behind them. And they're like, okay, punk rocker. I'm like, leak. I just kept saying leak and point, and they just were like, oh, whatever, it's fine. And literally like 10 years later, they burst. So little dumb punk rocker living in the back of a van knew something about leaking. Anyway, so that's why, Colton, your question is fabulous. It's fabulous because you have to know when to apply a margin. And the answer is simple, whenever you draw a sample. Whenever you draw a sample and base anything based on that sample, that thing needs to have a margin. Whether it's the average length of a frog, the average survival rate year to year of a frog, those are what I'm dealing with right now with whether it's our percentages back here, they need margins because they're incomplete, because they're based on samples. The error in the margin of error, the margin is easy, it's the plus or minus. But the error is because there's automatically error because we didn't measure every single person in the population. Is that fair? Okay, awesome. And the big thing is this. The big thing is this. I want to focus on this word probability, because that's what we're really talking about today, and we started talking about it on Monday, and we're talking about it on Wednesday. What is a probability? last class I gave you all a single die, and I had you roll it. And I think we bet on 6, but this was Monday, and it was a 6, it was 6 out of thank you. I thought we bet on 6. And I asked the question, I said, what is the chance that you roll a 6 if you throw a die? And you all said?
1 out of 6.
You said 1 out of 6. Okay. And then I asked you, why isn't it 50-50? Because I said, you either roll a 6 or you don't. So there's 2 outcomes. Why isn't it 50-50? And you said, time to bust out some dice, I think. It's time to bust out some dice. I think we need to, we can't be talking about dice. Oh, is that okay with the numbers? They always bother the hell out of me, okay? Numbers okay? They bug the shit out of me. I can't even use them correctly. Here we go, Mindy, there you go, Jonathan, and you go Eden, and you go Donovan. Listen, I want to hear from you in a second. You answered my question, but I talked over you because I'm a rude bastard. No, I'm a rude bastard. Let's inarguable. Okay, so the chance of rolling a 6. You told me it's 1 out of 6. My question back to you is, why is it not 1 out of 2? Because either you roll a 6 or you don't roll a 6. And Elizabeth, you said, because my simplistic answer does not take into account the fact that when you throw a die, there's 6 possible things that can happen. And all of them are the same likelihood to happen. Okay, thank you for that. I appreciate that. It's the same logic when I think I asked this question too. What's the chance I get hit by a car when I walk across that crosswalk today? Well, I either do or I don't, so therefore it's 50-50. Which is not true. Because if that were true, I'd be dead multiple times over by now. I would have been hit 50% of the time. So the first thing I want you to think about was probabilities. The first way I want you to think about probabilities is it's a long run frequency of occurrence. It's a long run frequency of occurrence. So, let's go back to my, what's the chance I get hit walking across the crosswalk? So far, knock on wood, I have never been hit in any of the crosswalks at COCC in 15 years. I've come close a couple times. I've gotten to the point where I'm looking up and I see the car's not gonna stop, so I jump back and I slam on the roof as they go by. And then they stop in the crosswalk, so I figured I'd call it a win. But if I had not been paying attention, this is why, please, I see students all the time texting as they walk through the crosswalks. Don't do that. Because chances are the goddamn car's texting too. So just pay attention. It's the law that says they have to stop, but you can't sue them when you're dead. Okay, let's go back to this 1 in 6. We've established that there are 6 sides of a die, and we've been told there's a 1 in 6 chance of rolling a 6. Tell me what the 1 in 6 means. Use the 1 in 6. You just told me the chance of rolling a 6 is 1 out of 6. Describe what that means for me without using the word chance or probability or likelihood or anything else. Explain what the 1 out of 6 is in reference to. What does that mean, 1 out of 6?
Use times.
Say that again. You can use times. Yes, because that's not a word that... the word time does not mean probability, chance, or likely. It just means trials.
Okay, so 1 out of 6 times you get.
I roll a die.
Yeah.
I'm going to get a 6.
You're gonna get a 6.
I love this. I love this. Hang on. I'm going to get 6 dice. Okay, Elizabeth, I want you to look at these, make sure that they're legit. I just grabbed 6 dice off the top. Is that legit? Okay. Here I go. Hold on. I love this butt. I'm going to roll. Elizabeth. Shit. I rolled 0 6s, Colton. You said butt. Hold that thought so I want to hear you too. I promise. Colton, give me your butt.
I don't know. Honestly.
Oh, you said butt.
You said stop thinking.
Oh shit! God damn it! Never stop thinking in this class. I got 2 more days. You never stop thinking. Sophie, what are you gonna say?
Well, to me, 1 out of 6 implies like you're rolling it 6 times, and then 1 out of those 6 times you're rolling it, you get 6.
So if I may, I just rolled 6 dice simultaneously. Is that not legit?
No, but I'm saying like
Oh.
that doesn't make sense to me. Like
Good!
No, it's not saying like 1 out of 6 numbers on the die. It's more saying like 1 out of 6 times you roll it.
Give me. So first of all, the first thing you said is the reason Vegas uses them in their casinos. Because literally, if you think about what Vegas uses in its casinos for its games, it's stuff that they know the behavior of. They know how dice behave. They know how decks of cards behave. They know how roulette wheels behave. Do you ever wonder why they change decks of cards out so frequently? And why they change, you never thought about this stuff, you're like, no, whatever, I just figured they do it. They do it so that the dice stay brand new, so they don't develop any kind of imperfection that might give the gambler an advantage. Yes! Have you ever heard of the phrase cooked dice? Or loaded dice? You ever heard cooked or loaded dice? What people used to do before casinos really paid attention to quality control was they would take a pair of dice, put them 7 up, a sum of 7. This is why I wish we had the craps quiz on Wednesday, but it's okay. 7 is a good roll in craps. If you roll a 7 on the first roll, you win. So they would take a pair of dice, put them in the oven, turn the heat on just enough to start melting the plastic. And what would happen was the dice would start to melt, not visibly perceptively, but more weight would go to the bottom, which would give that 7 a little bit more of an advantage to land up than down, because the heavier side would land down. Does that kind of make sense? And with a game like craps, it's such a tight margin, that was enough to make the game profitable for the player. Casinos don't let you do that. They don't let you be, hey, I got my own dice, it's good. They're not gonna let you do that, they're gonna control that. Fair? Okay, now, so Sophia, what you just said was so important. Yes, 1 out of the 6 sides is a 6, but it doesn't make sense that if I roll 6 dice, I'm gonna roll next to you now, I've got 6 dice right here. And here we go, 6 more dice. Now Elizabeth, how many 6s did we get over there?
0.
We got 0. Let's see how many we get over here. How many did we get?
1.
We got 1 out of 6 over there. Shit, hang on. Need 6 more.
It's like perfect.
But it's not, it's below perfect, isn't it?
I don't know.
Because wouldn't 1 out of 6 be 2 out of 12? Right? I'm still pissed because it's not 1 out of 6 yet. So,
So you're saying that all
Over
would be
here.
6?
how many 6s?
1.
1. Still not perfect. Because now it's 2 out of 18 and it should be
3 out of it.
3 out of 18 or 1 out of 6. They're all 1 out of 6. I just said 2 opposing things. I said it should be 3 out of 18 because everything's 1 out of 6. But this is flying in the face of what Sophia just said. So my question is, where does the 1 out of 6 show up? Not the fact, yes, I totally agree. There are 6 sides to the die. There are 6 sides to the die, and one of them is a 6. But how do we utilize that fact when we actually roll some dice, Eden? How many 6s? Shit!
Well,
And not only that, 1, 2, 3, 4. Not only, I only saw 2 6s, I saw 6 goddamn 1s. 6 goddamn 1s. What is the chance of 1 on a die? It's 1 out of 6. So why the hell is it 1 out of 4 right now?
Random.
Say it again.
Random.
Say it again. Just keep saying it.
Random.
Keep saying it. Elizabeth, I need you to keep saying that.
Random.
Thank you. Keep it going. Keep it going.
Who's gonna stop me? Random. Random.
Hang on. Okay.
Oh, okay.
This is a simulator which is going to roll a die for us. It's not as fun as actually rolling dice. I guarantee it's not. Rolling dice is actually more fun. I'm going to roll 6 more. Is that yours right here? Ah! 2 6s on that one. Son of a bitch. We're almost back in business. What am I saying? Almost back in business. What am I saying?
back to our statement.
Say it again.
Back to our statement of 1 in 6 chances.
So what is the 1 in 6 really talking about?
Out of there.
Probability.
It's a long run frequency. In other words, it doesn't mean that every 6 rolls you're going to get a 6. It's not a promise. We saw that on the first set of rolls.
That's why I came with the butt.
That's where I thought you were going with the butt. But I don't just stop thinking because I'm an idiot. So if I roll, let's see, I'll do 6. There's 6 rolls right there. Total roll 6. So far, we've gotten 3 2s, a 1, and there's one of our goddamn 6s. But we've gotten no 5s, no 3s. But what should I do?
Hit it again.
So now we're gonna keep rolling.
Look at that.
What's evening out?
Where is the, say that again, Elena?
It's evening out.
Oh my God!
Happening.
It's happening! What's happening?
It's hitting the ones.
The 1/6 is happening, but it takes what for it to happen?
The long run.
Thank you, a long run frequency of occurrence. You need to see. That's why, Colton, your answer to the extra credit was so good. We need more trials. Yes, because in a small sample, you can have highly volatile reactions to the experiment. You often see small samples that result in kind of crazily weird results, but that's because on a small sample, an element of 1, a U, in a very small y'all, is a huge percentage difference. Think of the difference between 3 sevens and 4 sevens. If you only have a sample size of 7, and you go from 3 out of 7 to 4 out of 7, that's a huge difference, 14% difference. You shouldn't even use the word percent, in my humble opinion, because percent means there's at least 100, right? Fair? Okay. Oh, sweet Jesus, look at the 1/6. Now, are they exactly 1/6? No! Look at these numbers. They are not the same. They're not the same. Look! Exactly. But, and the margin of error has shrunk. Just so you know, that margin of error is not exactly
But I
0.
bet, like, if you had one on there, they would be.
Yes. It's just rounding to 0 because there's so many trials now. We got 2,500 trials. The margin has shrunk away to nothing. So the point is for this, that you're going, I'm going to let it run over break. But the point with probability is, with things like dice and coins and cards and one-arm bandits and the roulette wheel, we can look at everything and know what the chances are. But meaningful probabilities outside of a casino, like insurance rate probabilities, the only way you can get them is by doing studies. And the study is necessitated upon, or the validity of the study is necessitated upon getting a good sample that's large enough to have a meaningful margin of error. In this case, I'm going to ignore margins for the most point for the rest of the discussions we're going to be having, but just realize Colton's statement from before, you need them whenever you draw a sample. We're going to be able to draw lots and lots of samples using these simulators, which is nice. We can trick the margins away as small as we need them to be, which is good. And you'll study more of that in stat classes anyway. But the big thing about probabilities, Elena said, is long run frequency of occurrence. It's all about that. Yes. Okay? How about that run over break? Let's take 5, yes? I think you all need a break from me. Yeah, I get excited about this shit. It's good stuff, and I love your input. Thank you, 8 o'clock in the morning on a snow day.